On number 2, we are told that the figure shows two perpendicular lines, S and R, intersecting at point P in the interior of a regular hexagon. So since these are perpendicular lines, they would be similar to the x and y axis on a coordinate plane, intersecting at right angles. This is a regular hexagon. Remember, by being told it is regular, that means all the sides are congruent and all the angles are congruent. Line R is bisecting two of the sides of the hexagon, which means it's going through the midpoints of those sides. And line S is parallel to two sides of the hexagon, so it's parallel to that side and this side of the hexagon. We want to know which transformation will always carry the figure onto itself, and selecting all that apply, so more than one of these could be true. So I'm going to use some patty paper just to demonstrate which of these will work in transforming this figure onto itself. So if we reflect across R, remember that a reflection is a flip. So I'm going to flip the paper and line up line R again with itself, and you can see our figure looks exactly like it did to begin with. So that means that yes, this reflection across line R is one of our solutions that will carry it onto itself. So now if I get back to where I started and we look at a reflection across line S, now I'm doing a vertical reflection this way, up and down, lining up with S, and again my figure looks exactly the same as it did to begin with. So we have another transformation that will carry the figure onto itself. Let's look at part C. Part C is a 90-degree rotation clockwise around point P. So remember, 90 degrees is a fourth of a turn. We want to go clockwise, so we're going this direction with our rotation. So if I turn my paper 1/4 of a turn clockwise, does my figure line up with what it was to begin with? And hopefully you can see that no, it does not. So our choice C is not one of the transformations that will carry it onto itself. Okay, I'm going to line it back up to where it started again, and we're going to look at a rotation of 180 degrees about point P. So we don't have to say which direction with 180 degrees. Remember, that's half of a turn. So here's a fourth of a turn. Here's another fourth, which makes a half turn altogether. And again, does my figure look exactly like it did to begin with? It does. So that's another one of the transformations that will carry it onto itself. Let's go back where we started. A 270-degree rotation about point P. It doesn't tell me which direction. So remember, when it doesn't say which direction, we assume counterclockwise. So 270 degrees would be a fourth of a turn 3 times. 90 times 3 is 270. So here is 1/4 of a turn. Here's another fourth of a turn, which we remember is 180 degrees. And then one more fourth of a turn makes my figure look like this. So does that look exactly like it did to begin with? No, it does not. So that's not one of our answer choices. So A, B, and D, are the correct answers for number 2. I did want to show you just a couple of other shapes as well, just to make sure that you understand all the reflections and rotations that can occur. So I made a square in the same scenario, and I did that on patty paper as well. So I just wanted to show you that both of the reflections work. If we reflect across S, we get exactly what we started with. If we reflect across R, we get exactly what we started with. If we do a 90-degree rotation with a square, since all the sides are congruent, it looks exactly like it did. If we do 180 degrees, it looks exactly like it did. If we do 270 degrees, it looks exactly like it did. Okay, so all of those would apply to the square. Let's look at a regular pentagon. Again, remember, regular means all sides are congruent. If I reflect this figure over S, it would look this way. It looks exactly like it did to begin with. So reflecting over S would be one way to transform it onto itself. If we reflect across R, I flip the paper this way. Does it look like the pentagon did to begin with? No. So in this case, a reflection across line R would not work. If we do a 90-degree rotation, that's a fourth of a turn. My pentagon does not look the way it did to begin with. If we do 180 degrees, it does not look like it did to begin with. If we do 270 degrees counterclockwise, remember that is 1/4, 2/4, 3/4 of a turn. So that does not look like the figure did to begin with. So the only one that would apply to the regular pentagon is a reflection across line S. That's the only one that would map it to itself on the regular pentagon. So just be careful with whatever shape you're given on your test to make sure that you check all of those transformations.